Hello everyone. So this is a video where we focus on the process and concepts associated with a certain topic. For today's video, we'll be focusing on AI senses in games. However, to keep things simple, we'll be focusing on a particular component of AI sensing and won't be extensively covering different parts of Unreal's AI in this tutorial, as we'll be assuming that you've covered those areas. For today's goal, we'll hope to achieve some simple custom functionality that extends the site configuration of the perception component. Recently in the past week, I've watched a couple of videos associated with AI. However, I looked at how I can provide a simple extension of the present perception component that can be used to provide a much more realistic AI sense. That's where I encountered a blog post from Gamasutra on the perfect organism, which looked into the AI of alien isolation. A link to this will be down below. That's why I read up on the use of what is known as a menace gauge. That is a simple metric that allows for the system to understand how much it was pressuring the player. Now, this got some sparks going. If I were to implement this into my enemy's perception, it can determine the behavior based on how the value or metric is calculated, which is a step off the current setup that utilized a simple Boolean sequence which detected whether the player is seen or not. Now, we would get started, but first expanding on sight. Now, another video by AI in Games which I looked into explained how sight is utilized in alien isolation. To keep this straightforward, the sight sense for our AI will be divided into separate zones within the view cone: a normal view, a focused view, a peripheral view, and close view. But for my example, I will be looking into the first three. I'll also provide a link to the video down below for more context on alien isolation's AI. With this, the different view cones will now have different sensitivity or signal strength between each other. Now, I find that this is a very straightforward concept to implement into AI senses. However, being quite fresh into the Unreal editor, I do feel like quite a noob at a lot of things. That, and also quite long compile times on my computer, and the number of crashes I kept having. Now, into the process. As I've mentioned before, I already have a project up with a set of navigation nodes alongside an enemy character that contains its own AI component. In your enemy, ensure that you have an AI perception component attached and an AI perception stimuli source component on your player. For the purpose of this video, movement on the enemy AI was disabled to closely demonstrate the code and process at work. Now, to start off, we need to get things configured, so register your sense configuration for sight in your AI enemy, and set your configuration to whatever you like, but in my case, I typically kept my setup to a much shorter radius as the scene platform is a little small. However, widen the sight FOV so that it closely represents human vision. And in your player, make sure to include the AI perception stimuli source component, then check that it registers as a source and includes the AI sight as part of the register array. Now, with that over, our AI enemy should now be able to perceive its surroundings, which is good but fairly basic. The sight configuration of the AI perception observes nearby stimuli within its view radius. And in our code, all it does with that is to switch a bool variable to determine whether the stimulus is seen or not. This is modified in the sensePlayer function developed prior, which is passed as a delegate in our beginPlay function to be triggered whenever a sight stimulus is detected. However, with that concrete determination of the enemy's reaction to the player's presence, the AI can be a little jumpy on detection. Instead of immediate reaction by the AI, we will only use the bool as a determination as to whether it is in view for our calculation to do its work. Now, I created two different sets of variables, one a Boolean and the other a float pertaining to the AI's curiosity and whether it's threatened. The bool in this case enables for some concrete switches if the value has exceeded a certain threshold. And with both values set with an invisible anywhere property, I can have it seen in my editor. Next, I've added a variable named the minimum focus radius, which marks the closest radius where the AI's awareness is much greater and as the maximum range of the focus view. I've included some threshold values set to edit anywhere, which checks against the metrics and can be used to switch the accompanying bool variables. Lastly, I've included some sensitivity variables, which I can use to modify the AI's sensitivity to the stimuli. But for this video, they are set to 1. Now, I've also included some additional methods which I'll go over later during the course of this video. But firstly, I want to determine curiosity. Now, unlike the threat, curiosity encompasses the entire view, whilst threat is primarily focused when the player is in direct focused view of the enemy. So, let's write that out. Now, it's optional, but I've included some screen debug messages so it can actively monitor the curiosity during gameplay. But above that, we need to determine the total curiosity of the AI. So let's write a method called calculate curiosity within the if statement. Within the function, we first determine the dot product from the AI to the stimuli. This is done by first getting the normalized direction between both actors, in which we set its tolerance to 1. This, however, did take some time to get working, as I discovered I was using the wrong function from the f vector to get the normalized values, and that my IntelliSense was throwing me off in the very wrong direction. From there, we set the f vector's dot product function to the arguments of the AI's forward direction and direction of the stimuli, not forgetting both of these values are also normalized. This gives us a float result between 1 and -1 as either being forward or behind the AI. Now with this, we run a bool check on whether it exceeds 0.7 as being within the normal view of the AI. This will contain the highest increment for curiosity, then calculate the distance between entities and include an if statement containing the mid-increment value if that condition was true. And then below, as the last increment, it will contain the lowest value as the base. With this, curiosity can be determined on its direction and distance when sensed, and you can see this working. Make sure to reset back to 0 when it leaves the view of the AI or when it's not sensed. Now, lastly, threat. Unlike curiosity, this is much easier to determine. Through vision, when the player is detected within the focused range of the AI sight, the threat value increases. To do this, create a determine threat method which also performs a very similar setup for curiosity. Likewise, you can also optionally set up some debug messages to observe the values. When calculating it, you perform a similar dot product alongside calculating the distance of the player from the AI. We also use the maximum focus radius as our range for our focus site. This ensures that we also add the threat whenever the player or stimuli was to be within the AI's focus site. Additionally, the if statement compares to a higher forward dot product as the focused view direction is much narrower than the normal site. And when you play this out, you can see the threat result when the stimuli or player is in front of the AI. However, what we may notice is that the values go a bit over and under the range between 0 and 100. So we create another function which clamps the values. Now, as we have that all working, we ensure that we call all the specific methods during the update, and then let it play. And again, you can run AI debugging to reveal the senses at work. However, even for vision, this really limits the modification only during the visual detection of the stimuli, but with this metric setup, it can be adapted to be used on other senses. Now, this may be extra to the topic, but might as well. As the setup for the AI uses a delegate, it behaves more as an observer to events of stimuli interaction. From here, the setup I've been working on has a blueprint containing the fire function which checks for gunfire inputs from the player. From here, I create another node called report noise event, which is hooked up with the gun actor itself as the instigator and its position as the point of origin. Additionally, I've given it a tag of gun with a loudness of 100 and a range of 3000. Just don't forget to also hook this up to the fire function, that way it can only be triggered whenever the player were to fire the weapon. I've also set the child object gun to also the same tag gun so that the detected actor can also pass the tag gun when necessary. I've also modified the perception stimuli source to also register as a sound source, and modified the AI perception component on the AI enemy to include AI hearing as part of its configuration. Just don't forget to tick all the boxes under detection by affiliation. Now, when the delegate is called, it will call a function called process sound event, which checks the tag which we named gun, and then appropriately adds an immediate jump in threat and curiosity values, which can be used to trigger some behaviors. And as this sound stimulus expires, it will then reset those values back to 0 when no stimuli are detected. With this, it should cover the basic extension of the AI perception component, especially towards senses. However, with a metric setup, it can also be modified to account for detection of player walking and whether the AI has been hit. Additionally, you can do all away with a bull check for each metric and rely on a combination of values to produce a value that can be combined for determining behavior. But hopefully you've gained some insight today into using the AI perception component and some simple site coding for C++ on Unreal Engine. I find this useful as it can be used for my Unity development on structuring and understanding on how the visual senses will work, as well as into getting more insight into how to use the environment for Unreal Engine, as I, of course, have my fair share of errors and issues with my early development with it. Other than that, thanks for listening and hope you have a good one.